Well, hello, Algebra 2 students. This is Mr. Kelly. I'm at K-Town. Today we're going to be learning about probability. Now, I understand some of you may have never had the experience of, probability because it's been a while, maybe middle school. So we're going to go through and learn a lot of things. A lot of it is notation and definition. So we're going to get started. Make sure you pause the video as you need. Probability. What is probability? Probability of an outcome is the proportion of times that outcome would occur for a very large number of repetitions. It's somewhat like predicting, like if this were to happen lots and lots and lots, how often would a certain event occur? Now, the notation we're going to use, we use a capital P with parentheses, and then I'll just say A. And what this means is the probability that event A happens. That's the notation we use. So when you see a capital P with some parentheses, that means the probability of that happening. Okay? Terms we need to know. An outcome. An outcome is one possible result of an experiment. Now, an experiment is something you do, to see what is the outcome. We're going to flip a coin. We're going to spin a spinner or maybe play a game and see what happens there. That is an outcome. Another thing we need to know is the sample space. Now, the sample space is every possible outcome that can come out of the experiment. So the set of all possible outcomes. When you flip a coin, the sample space is heads and tails. Those are the two possible things that could happen. When you roll dice, when you roll a die, or sometimes they call it a number cube, the standard die is 1 through 6. Okay, so the sample space would be 1, 2, 3, 4, 5, 6. That's what sample space is. It's the set of all possible outcomes. And an event is one or more of the outcomes of the sample space. So maybe an event could be, the probability. The event could be that you roll an even number. Okay, notice there are several outcomes that could make up that event. A 2, a 4, or a 6 are all even. So the event probability of getting, I would write it like this, the probability of getting an even number. I would actually write it out, even. That would equal what? Well, there's 6 outcomes, so 3 out of 6. But we'll get into that in a second. First example, Sully rolls a 6-sided number cube, and that's dice. Okay, we're talking about dice. The sample space would be 1, 2, 3, 4, 5, 6. Those are all the possible things that could happen when he rolls the die. All right. Let's define event F as the number rolled is greater than 4. So let's look. Greater than 4. It doesn't say equal to 4. Greater than 4. So which one of these outcomes would satisfy this event here of being greater than 4? It would be this one and this one here. Okay, so those two events, 5 and 6, would satisfy that event. So let's write that down. 5. I'm going to write it in set notation. That means that 5 or 6 would satisfy event F. And what outcomes would not satisfy event F? Well, those would be 1, 2, 3, or 4. And even 4 is not greater than 4, so it doesn't work if he rolls a 4. So 1, I'm going to list them all out. Now, you can't say 1 through 4. We're just going to write them all out with these fancy set notation brackets. So we defined event F. F is that the number is greater than 4. I want to find the probability of F. That's how we write it, the probability of F. Well, there are a total of 6 outcomes, and 2 of them, 1, 2, this one. Why is that going? What is going on? This one and this one. Those are both wins, right? They're both outcomes that satisfy the event. So I would say that the probability of F is 2 out of the 6. And I'm not going to reduce that. Not in this lesson. We're just going to leave it the way it is. 2 out of 6. And the reason why is, it's easy for me to check where you're getting your numbers if you don't reduce it. So 2, because there's 2 possible outcomes out of 6. And if you reduce that to 1/3, you kind of lose, some of the information that's there. So we're just going to leave it as a fraction unreduced. Now the next one, find the probability it's even. So we go back to our sample space. We're always going to be looking back at that. The 2, the 4, and the 6 are all even. So I'm going to write the probability that it's even is going to equal how many? 3 out of the 6. So this means a probability. If I were to conduct, this experiment, which would be rolling the number cube, or Sully would, several thousands and millions of time, about 3 out of 6 of those times, which is 1/2, that does reduce to 1/2 of the time you should get an even number. And that should make sense because, half of those numbers are even. So that probability tells us how often an even number would occur. Let's look at a different example where we flip a coin, but this is, Bruss flips a coin 3 times. This is a favorite lucky coin here. This is called the Silver Sully dollar. I made that, I don't know. But he flips it 3 times. So let's talk about our sample space. The sample space is the list of all possible outcomes. So our sample space is capital S. Well, what could happen? Well, the first one could be a heads. Okay? And the second one could be a heads. And the third one could be a heads. So that is one possible outcome because he's going to flip it 3 times. What else could happen? You could get a heads, and then a heads, and then a tails. See how that's different? Okay, now I'm trying to be a little systematic here in the way that I do it. Okay, we have 3 heads. Change the last one to tails. What if we had heads? Let's change this one. Tails, and then heads. And then we could have a heads, a tails, and a tails, right? And then we could have, well, we've done all of those. We got to go switch to the tail. Could be the first one. All right, I'm going to pause the video and then answer the rest of the questions for example 2. Pause that video. Go. I think you can do it.
What do you think the chances are of a guy like you and a girl like me ending up together?
Okay, so how did you do? Here's my sample space with how many outcomes? Let's count them. 1, 2, 3, 4, 5, 6, 7, 8. All right, so there are 8 possible things that could happen if you flip a coin 3 times. You could get 3 heads, or it could be heads, heads, tails, heads, tails, heads, so on and so forth, all the way down till you get 3 tails. So let's define W as Bruss flips at least, so here's the key, at least 1 head and 1 tail. So what I'm going to do is I'm going to go and I'm going to underline all of the outcomes that satisfy this. So which outcomes satisfy? At least 1 head and at least 1 tails. This one's a no. This one's a yes. It's got 1 of each. That one's a yes. This one's a yes. This one's a yes. This one's a yes. This one's a yes. That one's a no. So there are 8 total outcomes, and the outcomes of, let's write these down because it's asking us the set which outcomes. So heads, heads, tails. So as you can see, we have all the outcomes that have at least 1 head and 1 tails. You need 1 of each, and that's 6 of them. That's awesome. Okay, now which outcomes would not satisfy this? There's only 2. That's ugly. Set notation. We have heads, 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 3 heads, or 3 tails. And those are the only 2 that would not satisfy that. Okay, so now find the probability of W. Remember, W is finding, at least 1 heads and 1 tails. So 6 of them out of the 8. There's 8 total. So the probability of W, we're going to write it like this. The probability of W is 6 out of the 8. Now, probability of 3 heads. You just have to go to the sample space here and look for 3 heads. Right here. That happens 1 time. So we're going to say the probability of 3 heads equals 1 out of the 8. It only happens 1 time. And find the probability of at least 1 tail. Well, look, at least 1 tail. Tail, 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 tail. All of these have tail. The only one that doesn't have tail is 3 heads. Notice how these are opposites. So the probability of at least 1 tail. So greater than or equal to 1 tail. That's how I'm going to write that. Or you can write it out in words. You can write it out in words, but that's 7 out of 8. But I wanted to show you that the opposite of 3 heads is, it's not 3 tails. The opposite of 3 heads is at least 1 tail. Right? If you're not 3 heads, then that means you have at least 1 tail. And so that's what those 2 things, that's how they're related. So next we're going to talk about the probability rules and more importantly, some notation. So the probability of any event has to be between 0 and 1, inclusive, which means it can be 0 and it can be 1. If the probability of an event is equal to 0, that means you have 0 outcomes out of the entire sample space. So the event will never occur. So that is a probability of 0. Now, if the probability is equal to 1, it means it is certain to occur. So all of the probabilities, regardless of what the event is, has to be between 0 and 1. And here's one way that we can write that. The probability has to be between 0 and 1. Now, here's a little clip to give you an idea of how some people understand probability. This is actually a clip of Mr. Brust in college. So Mr. Brust right here in college.
What are my chances?
Not good.
You mean not good like 1 out of 100?
I'd say more like 1 out of a million.
So you're telling me there's a chance? Yeah!
So 1 out of a million means there are a million outcomes in the sample space, and one of them would be in his favor there. It's not good, Mr. Brust. Not good. All right, now let's talk about some other words. The complement of A. Complement sounds like a good thing. It's actually the opposite. It's the set of all outcomes that are not in A. Okay, so the first example, find the probability of the complement of F. Now, how do we write complement? Well, we have to use some fancy notation here. We're going to write the complement of F is written as the probability, or I'm sorry, the complement of A would be the probability of A, but we put this little C next to it, and that C means the complement. It means the opposite, everything that's not whatever A is. Okay, so example 1. If you recall, example 1 had F was the number rolled is greater than 4. So the probability of F was 2 out of 6. Let's write that down. So if the probability that F will happen is 2 out of the 6 outcomes, then we know that the probability that F won't happen, or the opposite of F, has to be all of the other outcomes that aren't these 2. So that would be 4 out of 6. Okay, let's try the next one. The probability of the complement of W from example 2. As you notice, the probability of W from example 2, so when we flipped the coin 3 times, was 6 out of 8. That was the probability of W. So really, I don't even have to remember what W was. If I know that the probability of W was 6 out of 8, then the probability of the complement of W, so that would be written like this, little c up there as an exponent type, it's called a superscript. Okay, that would be 2 out of 8, because if 6 out of 8 of the outcomes satisfy the event from the sample space, then if 6 do satisfy, then 2 do not. So the complement is all of those that are not part of the sample space. Okay, now we're going to do some examples. I'm going to hold off. Let's get through about 4 different things first, and then we'll do examples of all of them. So if that's a little cloudy, don't worry about it. We're going to get to it. Next thing we need to learn, conditional probability. What conditional probability is it's the probability that an event occurred based on the fact that some other event already occurred. Okay, so if we know that B happened, then the way we're going to write this is the probability of A, given that it's a straight line up and down, given that B happened. Okay, that means the probability of A given that B happened. So B already happened, so now what's the probability of A? Okay, if we know that A already happened, then we would just write it like this, given that A happened. That would come second. And so the probability of B given A, that's how we would write that. So in the first situation, we know that B happened, and in the second situation, we know that A happened. Okay, so this is given B, this is given A. All right, as I said, we're going to do some examples in a few minutes. The next 2 things we need to learn, the difference between union and intersection. Now, union, look, see how union, you got a little U there? Eventually, we're going to have some notation down here, and see how there's a U right there that stands for union. But this is most frequently used with the word or. So if I have 2 events and I say, what is the probability that A happened or B happened, or even both? Okay, that satisfies in math. We're going to do inclusive of both of them. So either A can happen or B can happen or both can happen. The probability that A or B or both happen is written with probability, and we use that little U for union. Now, if it's not the union, it's probably the intersection. It's not or, one or the other. The intersection is and, okay, at the same time. You know, you have streets. All right, so here's your street. And then here's the other street. And we say, where's the intersection? It's this part right here. It's in the middle because it's on both of the streets at the exact same time. So if we're going to use the word and, what's the probability that A happened and B happened at the same time? That is the intersection of two events. And instead of a U, we're going to use an upside down U. That means intersection. Now, the way that I always tell kids to remember it, okay, the first one, the or, if you have A or B, that kind of looks like a boat. See a little person in there? And guess what he uses to paddle the boat? Oars. All right, that's not the best, but it is original. I did come up with that. And the other one, okay, the upside down, you can make an A for and. So this is the union, this is the intersection. So that's how you remember which one is which. Kind of important because this mastery check is going to be a lot about notation. So let's practice with example 3. We have Bean rolling a fair four-sided number die. Now, fair means that there's an equal chance of each of the sides being rolled on. So that means when you roll it, any one of them could come up and one no more likely than the other. Okay, we want to find the following. So let's look at this. I mean, there's a lot of weird, like this means 2, and remember that? That's the union. That means or. So the probability it's 2 or odd. This means the probability that your number is less than 3 and it's even. So you really have to know the difference between or and. You can just translate it to English if that helps you. These straight lines up and down mean given that, but we'll do those in a second. Let's first write down the sample space. So our sample space, what can happen when you roll this thing? You can get a 1, a 2, a 3, or a 4, and that's it. Okay, so for example, for the first example here, what is the probability it's 2 or it's odd? So is this 2 or is it odd? Yes, it is. So that one checks. This is a 2. That checks. That's a 2. And then 3 is odd. And then 4 is the only one that's not. So out of all those choices, 3 of them are 2 or they're odd. Okay, so that's how you do that. The second one here, the probability it's less than 3 and it's even. All right, let's do this again. Is this less than 3? Yes. Is this less than 3? Yes. Is this less than 3? No. Is this less than 3? No. Okay. And it has to be even. So which one of these are even? So notice how this is a little different than or. This is the only one that's even. It's both. It's less than 3 and even. So there's only one option here out of the 4 that is less than 3 and even. Okay, so for those two, it's pretty easy. You can write out them all and you can just check them and see which ones fulfill whatever you're looking for. Now the next two, you have to know which way you're reading this. This says the probability that it's even given that it's a 1 or a 2. So we're only looking, I'm not even looking at the rest of the sample space. I'm only looking at these two answers. So it's out of 2. I can tell you right now it's out of 2 instead of out of 4 because it's only out of a 1 or a 2. That's a 2 total things. What's the probability it's even? So how many between a 1 and a 2, how many are even? 1 of them. So the probability that it's even, given that it's a 1 or 2, is 1 out of 2. And then the last one, what is the probability it's odd, given that it's even? All right, so given that it's even, that means I'm looking at this one right here, and I'm looking at this one here. Those are the even ones. So now it's out of 2. How many of those are odd? The probability it's odd, given it's even. Well, this is a silly one. There's none of them. It's going to be 0 out of 2. And remember, that's never going to happen. The probability of 0 means it's just not going to happen. We need more practice. So here's example 4. Use a two-way table to answer the questions. Here's some shortcuts here to help you. First, we have to complete the table. So right now, pause the video and fill in the table. All these missing spaces right here, this is, students were asked which teacher made the best videos on flipmath.com. The results are at this table right here. So we need to figure it out. It's based on boy and whether you're a boy student or a girl student, like which videos you like. So go ahead and fill that all out right here so we can answer the questions. All right, I was going to have you pause the video, but I'm thinking maybe you don't know how to do this. It's kind of easy. This is between Sully, these are all the Sully video preferences. Add these two together, you get 108. So that's what this value is right here, 108. Because I add those together, this is the total. And then if I add all of these totals together, that's going to give me what? 200, and I get an 8 and a 2 there. That's going to give me 250 total students. So, double check the math, add it this way. So this number here represents all of these added together. So that would be what? 77. You do 118 minus 77. I get a 41 for that. And if you fill in the other row, you get 66 and 20. So you just have to know, like, they add the sum up and down to the total and horizontally as well. So the total number of students surveyed was 250, if I did my math correctly. And the total number of boys surveyed, just need to go across this row. I get 118. Now the total number of students who prefer Sully, I just go down the column. That would be 108 total students that prefer Sully. Okay, so suppose a student is selected at random from these that were surveyed. We want to find the following probabilities. So the probability the student prefers breast. This is a little shorthand. I know it feels like it should be 0, but just go with the numbers for this right now. Probability of those who prefer breast. It should be 107 out of the total. So out of 250 students, 100, how many breasts? 107 prefer breast. Okay, what's the probability that the selected student was a girl? So that would be this horizontal rows total. So it'd be 132 out of the 250. Now, what is the probability that they preferred breast given that it was a girl? So given that the student was a girl, that is only out of the girls. That's only out of 132. Now, how many of those students preferred breast? 66. That's how you do those. What is the probability that it was a girl, the complement of a girl? Okay, that means all of those that were not girls. Well, the probability of a girl, we already did that, equals 132 out of 250. So you just need to subtract 250 minus 132. Guess what that's going to give you? All of the boys. So this is it's going to be 1 minus 132 out of 250. So you just subtract from 1. And that'll give you the other half of it, right? And that'll equal 118 out of 250. Or you can just look at it and then add up all the ones that are not girls. Okay? The probability that it's a boy, given that they preferred Sully. So given that they preferred Sully means that this is only out of 108. And the probability that it was a boy would be 62 out of 108. The probability that they prefer Sully given that it's a boy. That's a different question. So it's given that it's a boy. So you look at the boys. There's 118 of them. So I know this is out of 118. Now the probability they preferred Sullivan is 62. Get the hang of it? So why don't right now you pause the video and complete the rest of these. Do the rest of it. Finish it. Go. Okay, so here's what I got after I've figured everything out. The only tricky one here, look at this one. The probability that the student was a boy given that they preferred Kelly or Sullivan. So out of all the students that prefer Kelly or Sullivan, that's a total of those two right there, 143. So then how many of those were boys? That would be the top number there, 77. So that's where that number came from. Check the other ones. Now, lastly, what we're going to do is we're going to write a statement. So you're going to write the statement based off of the probability. So this first one here is 20 out of 132. So 20, I've circled it, and 132. It is out of this, which is the row, which means out of the girls. So when I write this probability statement, it's going to be given that the student was a girl. And so what does that 20 represent? They preferred Kelly. So this is the probability they preferred Kelly given that the student was a girl. All right, how about the last one here? It is 66 out of 107. So here's 66, here's 107. So you need to write a statement. It's out of 107. That means out of breast. So it's given that the student prefers breast. That should be like 0, right? 0. But anyways, given that the student prefers breast, what is the probability? It's 66. So that would be that they are a girl. So that is the probability that the student is a girl given that they prefer breast. Hey, that's it. You need to get comfortable with the notation. You know, if you need, go ahead and print the corrective assignment off if you need more practice than what's in the practice packet. Hey, this is Mr. Kelly in Kaiserslautern. Remember, it's nice to be important, more important to be nice. See ya.